Hi, everyone. Let me just find my position here. We'll see how many of the tips I break. Okay, so I am Jacques Smuts. I am an Android developer at Nomanini. We operate all over Africa. Ooh, I just forgot something. Never mind. So we serve informal merchants all over Africa in a lot of places. And when I say informal merchants, it's people usually running like spaza shops and running out of their own homes or in a little container that they set up shop in. But a lot of times when companies say that, oh, we operate in Africa, then they make a big deal and they show a photo of a zebra or something. And then in actual fact, they operate in Cape Town or in Abidjan or in Dar es Salaam in Tanzania. And these are places where, I mean, colonization did its number and still does to an extent. But there's a lot of infrastructure and development there, as you can see. Like the photo is telling a big story there. But then on the edges of these more developed places, you go to, in, for example, Tanzania, further out, you get places that look like this, where the infrastructure isn't as developed. But, I mean, there's still cell phone towers. You can't see it clearly, but there is one in the background. And then these are the shops Nomanini tries to reach out to. And these are merchants who use our app to sell things like airtime, and data bundles, and pay for television and electricity bills. We give them a device like this, which I was supposed to bring along and show you, but whatever, at least I got a photo. But they also can use their own phones, and the phones they use tend to be very old. And as you can tell from the photos, like there usually is like cell phone towers nearby, otherwise they wouldn't be able to operate, but oftentimes the signal is very bad. And so we have to deal with bad internet, and how do you handle that? Now, this is a very broad topic, and there is so many things to talk about. So it's going to be basically me saying, this is what worked for us, and there's just more linked at the end. So, yeah, there are many suggestions I'm going to make, but there will be more linked at the end, just to kind of clarify that it's just too broad a topic. Okay, so one of the first things, and this has happened to me at every place I've worked for, just increase the timeout. Yay, we did it. And then, so usually in code, wow, this ratio is incredible. Can you read that, I guess? Okay, so you increase the timeout, and then, like, does that really make a difference? Does it help? It's hard to tell, but from what we could tell, yes, it actually makes a difference. It seems maybe a little redundant or dumb or something, but it makes a big difference. But it's complicated because different people maybe you want a shorter timeout for various reasons. And so what we found actually what helps is we use a server configuration where the server determines based on like where the person is and how good the connection is, and there's various other factors going into it. We can say, okay, this is how long the timeout is for this area. So like let's say in Tanzania we have one timeout and in Egypt another. What else can we do? A more aggressive retry policy. That's generally a good idea, but let's just look at the default first. There we go. Okay, HTTP. Again, the ratio did a number, sorry about that, but that is the retry and follow-up interceptor. And what it does in the OKHTTP, which I assume most Android developers use, but I mean there are others, it follows the HTTP standard that like the W3 consortium hosts, or at least it tries to. And just if you have to think for a moment, how many times do you think does it keep retrying before it gives up? Now, for me, my immediate thought was, I guess about 3, maybe 5 times, but the actual number is 20. It tries 20 times before it gives up, and that's just the default behavior. So it's already a little aggressive to begin with. But it's a bit more complicated than that because it only retries in certain circumstances. So, for example, if you have a phone or app on your phone, and it tries to connect online through, let's say, a cell phone signal, a cell phone tower, and it needs to find the host that your server is in the cloud, and then it needs to resolve that address and do the TCP, HTTP handshake, and like there's so many steps involved. So you're sending your packet, and if anything along this path towards doing a handshake with the server, if anything goes wrong, it can just keep retrying. There's no real cost involved because there's there's no real strong risk involved. But the moment you do a HTTP call where now you've done the handshake and the data is going into the server where, let's say, for example, you're requesting your balance. How much money do I have in my account? And this is something we have to do a lot because our merchants are using money. And if that fails, you can just go, okay, I'll just do it again. It's not a problem that data went missing because it's an idempotent function. And hopefully most of you will be aware of what that means and some of the implications. But in case you missed it, idempotent means running the same operation n times will always give the same output. So if I request balance over and over and over, I am going to get the balance, and that operation doesn't change the output, which is not true for other things where, for example, we have to do a transaction. We sell airtime. And then if you sell the airtime and something goes wrong and you're not sure if that airtime was sold or not because you didn't get a result from the server, if you have an aggressive retry policy, you will sell it twice or 3 times. And so the default HTTP retry policy that I showed before, it retries if it's an idempotent function. And so by default, it won't retry a transaction like a post call, which is going to result in more transactions going off, which you don't want. So it's pretty safe to begin with, just as a default. But maybe we want to make it more aggressive. Maybe we want to retry safely somehow. And how do we do that? Well, you make the post call idempotent somehow. How do you do that? So what we do, and I think this is kind of a fairly standard thing, is say you have an API call, okay, I think that's readable, where you send a user ID, you've got an amount and a product ID, and you're sending that to the server. And if that thing happens twice, 3 times, then the server will make it happen so many times. But if you attach a new unique ID to it, which, I mean, we call it a source reference, but you can call it a transaction ID or whatever. But the point is you generate a source reference based on that information that you're sending, as well as the time that you are creating that transaction. And then what we do is we hash it with SHA-1 or SHA-5 or MD5 or whatever. But the point is that it is a hash that will result in a unique string, and the server can read this and decide whether or not it's the same one being retried or not. So now the post call is idempotent because no matter how many times you retry it, the server will know, okay, it's fine. And so what will happen in effect is, let's say we've tried to do that first HTTP call of doing a transaction and selling airtime, then we missed it. The server couldn't return the result because of bad internet, because of the signal being lost, because of whatever reason. And now if you retry for a 3rd time, the server will know, oh, this is just the same one coming in again. We can just throw it out and return the result from the first one. And this is just sanitary API design. Most people working with money ran into this problem at one point and then had to implement something like this, figured out hopefully this is kind of a norm. But one of the big benefits is you can make the most aggressive retry policy in the world if you have this system in place. And we needed to do that. We needed to have a very aggressive retry policy because we have really bad internet that we have to deal at times. And it helped. It made a lot of merchants, first off, they don't lose money by accidentally doubling transactions. And second off, they are willing to wait for 2 minutes, 3 minutes, because it's a transaction going off. Like think of you standing in the shop and you're just waiting for the transaction, and they're willing to do that because it's money. So this works for us, but may not work for everyone. Is there anything else we can do? Now it gets a little complicated. Asynchronous architecture or offline first architecture. And like I said, broad topic, so there will be more links at the end. But just the basics of it is, if you have something that what Google calls a repository pattern, you have something like the UI layer or view model, it goes to a repository. The repository is in charge of managing the data with the cloud or the server, and handling it on a local database in Android. And then you also have additional things like a work manager or push notification service. And the repository can manage all of these things. And this helps a lot because sometimes calls can be made asynchronous. Sometimes they should be synchronous. It's always, you have to move things around a lot when you try and figure out how to make your app work better in an offline scenario. And this repository pattern makes it just so nice to just easily move things around until it works efficiently. But how do you know which things to work, which things to move around, which things should be synchronous or not? Like you can logic it out a lot, figure it out, but the best thing is to put it in practice. So practice without theory is blind, and theory without practice is sterile. Now, what he was trying to say here is we just need to rise up and do a revolution. But for our purposes, what is important to know here is that, yes, we need to understand the theory of HTTP, the W3 consortium standards of HTTP calls, all of those things. But we need to put our code in practice, see how it performs in this case, bad internet. And how do we do that? Well, one thing we can do is the Android emulator has some settings where you can say, make the signal strength less, or the network type. I'm not sure even if the network type makes a difference, other than visually or what the Android emulator thinks it's on. But what you really need is to actually limit the network somehow. So what I try to do is set up I try to limit our internet a bit, or use with a router you can do rate limiting very easily, but that's a bit limited. So with this company, local company in Cape Town, PJH Technologies, they built this thing for us, for Nomanini, called the Bad Internet Box, or BIB. And it doesn't just limit your internet, and you can set it's basically like a Raspberry Pi with a networking OS on there. And it doesn't just limit the internet speed, it also like randomly packet drops or randomly disconnects you. It gives you a horrible experience. And I was so happy with the product that I sent them this photo of just, this is how much I like it. And now a short animation. Let's see if I can get the video working. So as you can see, it's quite beneficial to have bad internet sometimes. Joking aside, the point is you need to actually use your app in bad circumstances. I like the Bad Internet Box, but whatever you need to use, thank you, to simulate a bad environment is the most important thing you can do. Okay, so next topic, old phones. So we are on minSDK 15. It's pretty terrible. And we are actually moving up to minSDK 21. There are good reasons why you don't want it too low. So at this point, this is in a popular library, Android library. Someone said, at this point, there's really no point in supporting anything less than 15, though. I would prefer people, not to encourage people to support users of no value on these ancient API levels. And this is, 15 is pretty ancient. In 2015. You probably know the name of the person. I don't want to bad talk anyone. But the point is that, this perception is there, and especially in America and Europe. But here in Africa, we know that those phones are still out there. People are still using them, even though maybe they shouldn't. But this is the best they can get access to. And so we have to deal with that reality. It's very difficult. And then what are the implications if you support old phones? So just in terms of development, the immediate thing that comes to mind for me is just various libraries require minSDK 19 or 21. And for good reasons. So Compose, there's Compose talks today. I wanna code in Compose, but not yet. OKHTTP 3 has minSDK 14. It's great, but all the new stuff is on 4, and that requires minSDK 21. Coil and Firebase, they capped a lot of their libraries and things. And there's many more. The moment you go minSDK lower than 21, you will find that you will be restricted one way or another in unexpected ways. But there's another implication. I can't talk too much about this because I am not a security expert, but the basic is if you want to support phones that only get security updates officially, according to Google and Android, then you need to be on minSDK 29. And I think most of you are not. But the lower you go, the more the security risks increase. And one of the big ones is, as alluded to earlier with OKHTTP, TLS 1.2, I think, is it's just the security layer is just terrible on the network calls on the very old devices. But then, do you put your users at risk, or do you not have them at all? And those are there's no right answer there. So moving on. Some of the other phone implications. So these are things that are not specified in the SDK, but this is usually what we have to deal with, is devices with a slow CPU, low memory, low storage space, small screens, unresponsive screen input, and unexpected bugs. So in terms of slow CPU, how do you deal with that? Again, I don't have time to go into everything, but the Android profiler that's built into Android Studio, there's many good articles and discussions on this. It helps a lot. And what usually happens, at least in my experience, is that you find one big bottleneck. You find this thing is eating our CPU, and then you clear it up, and then it's you get a 20% increase in speed or whatever, if you're lucky. And then there's one more big bottleneck. And that's just the process you go through. And everyone will have different bottlenecks. In low memory, how do you deal with that? Again, the Android profiler is very good. I recommend it. And it's usually bitmaps. It's usually images. So you want to use SVGs. You want to just reduce the quality if you have to. Use WebP instead of which is the optimized images. There are so many things, usually with image related, you can do to optimize for memory. Oh, and Leak Canary. I built an app for Nomanini, which if you use it for 3 hours, it crashes. Because our merchants use the app for 3 hours. Some of them they open shop in the morning and they just make sales, just non-stop on that device. It's incredible. And so if you have a small leak, as the Leak Canary says, it can sink a ship. And the Leak Canary helps a lot with that. Small screens. Again, this is just you can do an entire talk on small screens. The solution is, it didn't work. Well done. Oh, it doesn't want to go back. I guess we're stuck. So unresponsive touchscreens. We take for granted how good our phones are nowadays. Like, you touch a thing and it works. Your fingers are like maybe a bit oily or wet or something, and it still works. You just like rub the screen, it's fine. But the old phones didn't used to work like that. I don't know how many of you remember, like how frustrating. And you'd have these dead zones, and so these chunky designs helps a lot to make sure that the merchant, even if they have a dead zone, if like you make your buttons big, you make sure that there's lots of padding between buttons so they don't accidentally mess up. This is just good design in general, but it's enforced to be, like we have to be even stricter about good design. Unexpected bugs, oh man, the old devices have so many unexpected bugs that they don't comply to the Android documentation or the standards that they're supposed to. There's one where we ask for the location, and it's supposed to either send back nothing or send back the location, and it sends back a null, and then you get a null pointer error. And then Kotlin can't handle that. It just can't. It's like, no, it's not null. So you have to work in Java for just that bit, just to write a wrapper to say, yes, it's nullable. So Java's better than Kotlin. So just a very quick list of what works for me, just in terms of frameworks and technologies, is Kotlin, obviously, except for that one thing. Coroutines and Flow, and for testing in Turbine, just I love it so much. Like coroutines and Flow is just wonderful. And your big part of that offline design I mentioned is that you need to use things like Oryx, Java, or Flow. I prefer Flow, but whatever works for you. This one is just objectively necessary. Coin is great to develop for. I like Coin for dependency injection. Codeine as well. It's a nice framework. But it is not a compile time dependency injector. We used to use Coin for a very short time, and the startup times just went up a lot, which on the new phones is not that big a deal, because like, okay, it's slightly longer. But on the old phones, it's a very big deal. And so you have to use either Dagger or some sort of manual dependency injection thing you build yourself. SQLDelight, I like that a lot. Room is also good. I just don't have a lot of experience with it. Okay, HTTP, as I've said, is very good. The reason I just want to call this out is because a lot of people are going into Kotlin multi-platform and similar things. And if you don't use OKHTTP, the default retry behavior is none. If there's a single failure, it just stops. So you have to write your own retry behavior if you're not using OKHTTP for Kotor. But it varies. Just OKHTTP is just really good. The repository pattern I talked about briefly, and MVVM or MVI or whatever. And flow binding. Yes, shout out to Yang C of Reactive Circus, who built the flow binding library, because I politely harassed him to lower the minSDK from 21 to 14, and he did it. And that was just made a big difference for me, because I really like flow binding. And so finally we get to the theme here, which is, now you'll see the different part is highlighted. Practice without theory is blind. We do put our app in bad circumstances, and that is what you should do to see where the bottlenecks are, see what is the problem. But then how do you solve that? And oftentimes you'll see, like when I said with the CPU has a bottleneck in the code where there's one function that's really bad. You can't just solve that one function. Usually the problem is very foundational. You have to redo your entire architecture. And the only way to do that is to know the theory. You need to constantly be reading up. You need to figure out what the best practices are. Because the sad fact is, how to prepare my code for harsh environments is you need to follow best practices, the ones that we should all follow, but even harsher. Like all of the things that, I mean, it's kind of ironic, like if you code in a place like America or in Europe or wherever, in a richer area where people are all on the latest phones, you can get away with more. you can not handle offline very well because they have better internet access there. You can handle, like, for example, if you do have the bad API call going off where the transaction happens twice, that's not such a big deal. But our merchants are in a situation where if the merchant is arguing and saying, oh no, but there's extra money going off, people get into fistfights or worse. And so to protect their livelihoods you have to follow best practices. Obviously, now we're getting close to the end here, which is how to find the best practices. There's no right answer there. Best practices is constantly evolving. There's no one place you can just point to. And unfortunately, you have to just keep up to date if you want to find the best practices. But some clues is following open source contributors on social media. Watching a presentation is good, but I'm not going to tell you that I'm right here. Developerandroid.com has some recommendations, and also this is linked at the end, that are becoming better and better every day. So they've got these things where they say, we strongly recommend coroutines, but we only slightly recommend, for example, flow. But they have these recommendations, and they're just becoming really, really good at explaining when it's good to use them and when not to, and that kind of thing. Coding Personal Project, a lot of you know, is just so good for figuring out the best practice because you will run into problems. You'll need to read up the theory. There's the whole theory practice thing that I keep talking about. And then finally, open source project. Just contributing teaches you so much. Just looking through the issues, seeing what people argue about, it's really nice. And there's new projects that came up recently, and I'm just seeing all of these people argue about things that I thought maybe we've figured it out by now. No, we're not in agreement. So you need to kind of go from there. And I've left, I hope, a long amount of time for questions at the end. There you There you will find the links to further reading, as well as when this video is up, I guess the video will be there on the slide.